Hello everyone. In this module, let us discuss thermodynamics, spontaneity and entropy. Please subscribe to my channel, like, share and comment on my videos. So first law tells us about the interconversion of different forms of energy. It cannot predict the direction of the reaction or process. Direction of the reaction or process. So the first law cannot predict the direction of a reaction or direction of the process in which direction it is going on. For example, if you take PCl5, PCl5 decomposes to PCl3, Cl2. So all are in gaseous state. Here delta H is equal to, let us say, minus x kilojoule per mole. PCl5 decomposes to PCl3 and Cl2, delta H is minus. So if you reverse the reaction, PCl3 plus Cl2, we get PCl5. Now what is the delta H here? Delta H is plus x kilojoule. Since the direction of the reaction changes, simply sign of the charge, energy change differs. Now in this reaction, if you keep PCl5, PCl3, Cl2 mixture in a closed vessel, we do not know whether PCl5 decomposition takes place or a combination of PCl3 and Cl2 goes on to form PCl5. So this is the defect or limitation of the first law. So the first law for limitation of first law is that the direction of the reaction cannot be predicted. So the discussion just now we made, that is, if PCl3, PCl5 gives PCl3 plus Cl2. So if the mixture of PCl5, PCl3 and Cl2 are kept in a closed vessel, we do not know in which direction the reaction goes on. Therefore, this is a insufficiency of first law. So the insufficiency of first law is that it cannot predict the direction of chemical process or physical process. Now let us see some examples. Water flows from higher level to lower level. Higher level to lower level. Water flows from higher level to lower level. Similarly, when two bodies at different temperatures are kept in contact with each other, then heat transfers from high temperature to low temperature. So these two processes are spontaneous processes. Spontaneous processes means without applying any external agency to carry out these processes, they go on themselves. So spontaneous process are those which can carry on their own without the help of external agency. Just now we discussed that two processes, that is, water flows from higher level to lower level. So here again external agency is not necessary. The best example is in our houses, buildings, offices, etc. The overhead tank is kept at the terrace, and from overhead tank we get the water through pipes into different flats. Therefore water flows from higher level to lower level, which is a spontaneous process. Similarly, when two bodies at different temperatures, here the temperature is T1, temperature is T2. Temperature T2 is greater than T1. So when temperatures are different, when bodies at different temperatures are kept in contact with each other, then the temperature flows, heat flows from higher temperature to lower temperature. Therefore here heat flows from body B to body A. So this is also spontaneous process. Therefore spontaneous processes are those which can carry on their own without the help of any external agency. The word spontaneous does not mean that immediately or instantaneously. That is, the spontaneous process, it has the ability to initiate the reaction. Let us take an example, combustion of hydrogen gas. This is combustion of hydrogen. So this combustion of hydrogen, when hydrogen is ignited, it undergoes reaction spontaneously. That means spontaneous reaction does not carry on itself, but it has the potential to carry out. So if a spark is brought here, then reaction goes explosively. So if a spark is brought, then combustion of hydrogen goes on quickly. That means It has potential means ability, potential or ability to undergo reaction, If you take this example NaOH and HCl, we get NaCl and H2O. That is when acid and alkali mix, we get a salt and water. So this is spontaneous. That means while adding to each other, reaction completes. Whereas this reaction cannot be reversed back. That means if you dissolve sodium chloride in water, you will not get back sodium hydroxide and hydrochloric acid. That means the salt solution does not change either blue litmus red or red litmus blue. So this process is irreversible reaction. Strictly speaking, all the spontaneous processes are irreversible reactions. Now let us discuss the relation between enthalpy and spontaneity. A spontaneous process have potential to occur at a particular direction under given set of conditions. So spontaneous processes, they carry on their own in definite directions under given conditions. See, the spontaneous processes are possible because certain kind of driving force is responsible to pull out or to drag out the spontaneous process in the forward direction. Spontaneous processes carry on in forward direction because of some hidden force or driving force which is responsible for the carrying out. For example, flow of water from high level to low level. So when water flows from high level to low level, potential energy of water decreases. So when water flows from higher level to lower level, potential energy of water decreases. That is, the system moves towards less energy. Similarly, heat flows from hot body to cold body. That is, heat flows from higher temperature to lower temperature. That is, here also energy decreases. So arrow mark downside shows decrease in energy. In these processes, what happens? The system moves towards the less energy. Now let us discuss some more examples. Combustion of hydrogen. Hydrogen combines with oxygen. Hydrogen burns in oxygen and we get water. Delta H equal to minus 286 kilojoule. That is, heat releases. Heat releases means system moves towards the less energy. So energy is given out. So when energy is given out, the system is stable. In the same manner, combustion of carbon. Here also, carbon combines with oxygen to form carbon dioxide and the delta H is minus 394. That means energy decreases. So the decrease in energy leads the system to reach the stability. That means decrease in energy brings out the stability of the system. Similarly, combustion of petrol. 2C8H18 liquid combines with 25 molecules of oxygen, gives 16 molecules of carbon dioxide and 18 molecules of water. Here the energy released is 10,951 kilojoule. Therefore, here also energy decreases. So from all these examples and of course previous examples, it is understood that the system becomes spontaneous if delta H is negative. That is, the system becomes spontaneous if the energy releases. So decrease in energy leads towards the stability. So that is a spontaneous process. Now let us see some more reactions. Evaporation of water. You know that water evaporates at normal temperature. Evaporation means it changes from liquid state to gaseous state. In liquid state, molecules are very close to each other, whereas in gaseous state, molecules are far away from each other. Therefore, to change liquid state to gaseous state, the forces, attractive forces must be broken, for which it needs energy, and this energy is taken from atmosphere. So here delta H is positive. So even if the delta H is positive, the evaporation of water is spontaneous. So here it is spontaneous process. Though delta H is positive, it is spontaneous process. Similarly, other reaction, other process, dissolution of ammonium chloride. Ammonium chloride is a solid substance. It is ionic substance. So ions are held very strongly with each other when it is dissolved in water. As it is dissolved in water, the ions are separated. That is, the strong attractive forces are weakened, overcome, therefore it converts into ions. So the strong attractive forces are broken by taking the energy, and of course it becomes ions. So here what happens, as solid substance changes to liquid substance, ions are separated from each other, then ions are free to move from one place to another place. This is understood as, in solid substance the ions are in an ordered manner, whereas in liquid, in solution, this orderedness decreases. In the same manner, in evaporation of water also, in liquid state molecules are close to each other, that is orderly they are arranged, whereas in gaseous state that order decreases. That means from these two examples we can understand that a spontaneous process, in a spontaneous process the orderedness is removed or randomness increases. That means the system moves towards randomness. So here also delta H is positive, therefore it is also a spontaneous process. Spontaneous process. Similarly, decomposition of mercury oxide. The first two examples, they take energy from environment, whereas here it needs 903 kilojoules, which is not possible to take from the environment, therefore we have to heat. If we heat, mercury oxide decomposes to mercury and oxygen. That means though we supplied heat, the process becomes spontaneous. So from all these examples, it is understood that the system moves towards randomness from ordered manner. The system moves towards randomness from ordered manner. So the movement of system from ordered manner to randomness is considered as spontaneity or spontaneous process. Therefore, this is the shifting of orderly arranged system towards randomness is considered as a spontaneity or spontaneous process. So from all these discussions, we can understand that delta H, that is enthalpy criterion, is not only the parameter for deciding the spontaneity. Therefore, we need some other thermodynamic parameter to decide the spontaneous process or spontaneity of the system. In the previous reactions, some reactions are carried out with delta H as negative and some reactions are carried out with delta H positive. So it is understood that irrespective of the delta H, that is whether it is positive or negative, the system moves towards the more disorderedness or more randomness. That is, the system moves towards the stability. The system moves towards the stability. Intermixing of two non-reacting gases. Now let us make one more example. Let us take a vessel having two non-reacting gases which are separated by movable partition. So intermixing of two non-reacting gases A and B are taken in two vessels which are separated by a movable partition. So here this is one type of gas and this is one type of gas and they are separated by a movable partition. That means this can be taken out so that the molecules intermix with each other. So here the molecules intermix with each other. Black spots and white spots, they are different types of gases. See, the intermixing takes place, the system moves towards the more randomness. That means the system moves towards the stability. So randomness increases, stability increases. From all these it is understood that randomness increases, the stability of the system increases. So more disordered state or more randomness is referred to as more stability. The disorder or degree of randomness is measured by another thermodynamic parameter, that is entropy. So all the discussion went on to introduce another thermodynamic parameter to explain about the disorderedness or degree of randomness, and that thermodynamic parameter is entropy. Entropy, which is denoted by S. Entropy is a state function. It is state function because it depends only on initial and final states, not others, not intermediate states. Also, entropy is an extensive property, that is, it depends on the bulk of the substance. So, extensive properties are those which depend on bulk of the substance. So, delta S means change in entropy. Change in entropy can be found from S final minus S initial. Final entropy minus initial entropy. Now, entropy is defined as the ratio of heat absorbed by the system isothermally and reversibly at which it is absorbed. So, entropy is nothing but heat absorbed by the system isothermally and reversible conditions at that temperature. So, delta S, entropy change, delta S can be found by dividing the Q reverse, that is heat absorbed in reversible reaction, by temperature. Physical meaning of entropy. The physical meaning of entropy lies in its ability to provide a measure for degree of disorder or randomness of the system. Greater the randomness, greater is the entropy. We know that the arrangement of molecules or particles in solids, liquids and gases. So, in gaseous substances, the randomness is more. That is, the molecules are free to move from place to place. In liquid substances, it is less. Whereas in solid substances, the molecules or particles are held very tightly with each other. Therefore, entropy for solids is less than the entropy of liquids is less than the entropy of gaseous substances. That is, randomness or disorderedness, randomness of gases is maximum, whereas randomness of solids is minimum. So, now entropy of phase transition. Phase transition means the phase transition refers to the change of one state of a substance to another state, that is solid to liquid, liquid to gas. So, when a substance changes its state, it takes energy. So, for example, the conversion of solid to liquid. Conversion of solid to liquid takes some energy at its melting point. Thus, entropy of fusion may be defined as the entropy change. Entropy of fusion is defined as the entropy change taking place when 1 mole of the substance changes from solid state to liquid state at its melting point. So, here this is solid to liquid, solid to liquid. So, entropy of liquid is greater than entropy of solid. Therefore, delta S, that is change in entropy, equal to entropy of SL minus SS. This S represents entropy, this S represents solid. So, this is nothing but delta H fusion. Delta H fusion by TF. TF means fusion temperature. Now let us discuss the entropy of vaporization. Vaporization means liquid substance changes to gaseous substance. For liquid substance, the randomness is less when compared to gaseous substance. Therefore, when liquid substance changes to gaseous substance, the randomness increases. That is, entropy increases, which means entropy is positive from liquid to vapors. So, the entropy of vaporization is the entropy change taking place when 1 mole of the substance changes from liquid state into its vapor at its boiling point. Therefore, entropy S vapor is greater than S liquid. Therefore, S final, that is entropy of vapor, is greater than S initial, that is entropy of liquid. Therefore, delta S is equal to S final minus S initial, therefore which is equal to greater than 0 or positive. Now let us do a problem based on these discussions. Calculate the entropy change. Calculate the entropy change when 38 grams of liquid water evaporates at 373 K. Delta H vaporization of water is equal to 40.63 kilojoule per mole. Therefore, here delta S vaporization is equal to delta H vaporization by TB. TB means boiling temperature. Then what is the delta H vaporization for water? 40.63. What is the vaporization boiling temperature? This is 40.63 by 373. Of course, this comes in kilojoules. So if you multiply with 1000, you will get in joules. Therefore, so if we calculate this, we get 109 joule per K minus 1 mole minus 1. Now entropy change for 36 grams. So delta S for 36 grams of water is equal to 109 by 18, that is for 1 mole into 36 is equal to, we get 218 kilojoule. Joule, this is not kilojoule, this is joule, this is joule per K minus 1 mole minus 1. So this is the answer. This is the answer. Now let us do a problem. Predict the sign of entropy for each of the following changes of state. Mercury, liquid mercury changes to vapor. Solid silver nitrate dissolves in water to release respective ions. And gaseous iodine. Now we know that entropy is the randomness. So entropy is denoted by letter S. So S is nothing but randomness. S is nothing but randomness. That is, entropy is nothing but randomness. So randomness is more for gaseous substances than liquid substances than solid substances. Therefore, the order of randomness, order of randomness of gases is greater than liquids is greater than solids. Now, so change in entropy delta S equal to S final minus S initial. S final minus S initial. Now let us see the first one. Mercury liquid changes to mercury gas. Therefore, for gaseous mercury, S gas is greater than S liquid. Therefore, change in entropy equal to S final. S final means entropy of gas minus S initial. Therefore, this is nothing but greater than 0 or positive. Similarly, second question, silver nitrate, it is solid. So, solid changes to ions. Solid changes to ions when it is dissolved in water. Since ions are there, these ions move rapidly in the solution. Therefore, the entropy of aqueous solution is more than that of solid. Therefore, delta S is equal to S final minus S initial. So here final is greater. S final is greater than S initial. Therefore, delta S is greater than 0 or positive. Now on the other hand, the third question, now let us do one more problem here. Entropy of vaporization of acetone is 93.0 kilojoule per mole. If the boiling point of acetone is 56 degrees centigrade, calculate the heat required for the evaporation of acetone per gram. So here delta S vaporization is equal to 93.0 kilojoule per mole. Now what is the formula? What is the relation between delta S and delta H? So delta S vaporization is equal to delta H vaporization by T. T means boiling point. So what is the temperature given here? Temperature is equal to 56 degrees centigrade, equal to 56 plus 273. How much this is? This is nothing but 329 Kelvin. Now delta S vap. So this formula, if we use 93.0 is equal to delta H vaporization, you have to find. by temperature 329. Temperature is 329. Therefore, delta H vaporization is equal to 93 into 329. This is for 1 mole of acetone. So this is for 1 mole of acetone. 1 mole of acetone. What is the formula of acetone? CH3COCH3. Therefore, molar mass equal to molar mass of acetone CH3CO CH3 is equal to 58. If you calculate all this, you will get 58. Therefore, enthalpy change for 1 gram of acetone. 1 gram of acetone is equal to 93 into 329 by 58. So the final answer is 527.5 kilojoule. So this is the answer. Now let us discuss the relation between entropy and spontaneity. Now let us take different examples. If non-reacting gases are mixed with each other, what happens? See here, this is one type of gas and this is one type of gas, and they are separated by a movable partition. Then when the movable partition is removed, all the gases are mixed with one another. Therefore, what happens here? The randomness or entropy, randomness increases. Randomness increases means delta S is greater than 0 or S final is greater than S initial. S initial. In the same manner, when a drop of ink is added to water in a beaker, see this is the water, this is the blue ink. This is water and this is the blue ink. When blue ink is added, gradually what happens? All the water turns to blue color. Gradually all the water turns to blue color. That means the particles of blue color disperses all along the water. That means the particles scatter. That is the randomness or disorderedness increases here. Therefore, randomness increases. Randomness increases means delta S is positive. That is, S final is greater than S initial. So here also, in a container, in a box, if you keep blue marbles one side and yellow marbles on one side and shake the box, when the box is shaken with different colored marbles orderly kept initial, all the colored marbles they mix among themselves in a random manner. Therefore, here also entropy increases. So, in this case also entropy increases. Now, in all these, whatever the process we discussed till now, if we observe them carefully, they are considered as isolated systems. They are considered as isolated system. So, in all these, that is the intermixing of non-reacting gases or mixing of blue ink in water or mixing of different colored marbles in a container, in these processes, so neither energy nor matter exchanges with the surroundings. Therefore, all these systems are referred as isolated systems. In all those processes, entropy or disorderedness or randomness increases. So, in other words, entropy final minus entropy initial is greater than 0 or S final minus S initial is greater than 0. The above discussion led us to make a general statement, that is, in isolated systems, the process will be spontaneous only if the entropy change of the system is positive. In isolated systems, the process will be spontaneous only if the entropy change of the system is positive. That is, delta S system is greater than 0. Then what about non-isolated systems? In non-isolated systems, energy and matter exchanges with the surroundings. Now in non-isolated systems, let us take some example, that is freezing of water. Freezing of water. So water liquid changes to ice H2O S, that is solid, at 272 Kelvin and at 1 bar pressure. So water freezes to ice at 272 Kelvin and at 1 bar pressure. And here, so delta S equal to minus 21.85 joule K minus 1 mole minus 1. Since delta S is negative, it gives an idea that the freezing of water or this process is not possible. Since delta S is negative, it gives an idea that this process not spontaneous. But it is our common experience that when the temperature falls below 0 degrees centigrade, that is 273 Kelvin, water changes to ice. On the other hand, if you take melting of ice, H2O solid gives H2O liquid. So delta S at 272 Kelvin 1 bar pressure is positive. So delta S for this process, that is conversion of or melting of solid ice to liquid water, delta S is positive at 272 Kelvin and 1 atmospheric pressure. Non-isolated systems are in contact with the surroundings. Non-isolated systems are in contact with the surroundings. As the non-isolated system is in contact with surroundings, it may exchange energy apart from matter. Therefore, energy exchanges with surroundings. Energy of the system exchanges with surroundings. Thus, change in entropy of the system also brings the change in the entropy of surroundings. So, change in entropy of the system also brings the change in entropy of. So, change in entropy of the system also brings the change in entropy of the surroundings. In melting of ice, what happens? Entropy changes. Let us take the example of freezing of water. When water freezes to ice, what happens? Energy is given out. Energy is given out means delta S is negative. Since the system is in contact with the surroundings, what happens? As the system gives the energy, this energy goes into the surroundings. Therefore, the released energy is absorbed by or given to surroundings. Therefore, delta S surroundings is positive. Delta S surroundings is positive. That is, when the system loses energy, then surroundings gain energy. When the system gains energy, surroundings lose energy. So, for predicting the spontaneity, the total entropy should be considered. Total entropy should be considered. What is meant by total entropy? Entropy of the system and entropy of the surrounding. So, total entropy, S total is nothing but system plus S surroundings. S total equal to S system plus S surroundings. S system plus S surroundings means it is nothing but universe. Therefore, S universe equal to S system plus S surroundings. So, S universe equal to S system plus S surroundings. Now here, for the freezing of water, delta S system is equal to minus 21.85 joule K minus 1 mole minus 1. Similarly, delta S surroundings equal to plus 21.93 joule K minus 1 mole minus 1. Therefore, S total equal to delta S total is equal to S system plus S surroundings. This equal to minus 21.85 plus 21.93. So, what is the change? Change is plus 0.8 joule K minus 1, mole minus 1. So ultimately delta S becomes positive. Since delta S becomes positive, therefore this process is spontaneous. So for a system to be spontaneous, we have to take S total. S total is S total equal to delta S system plus S surroundings. So if S total is positive, then system or process is spontaneous. Finally, we define the second law. Second law of the thermodynamics states that the entropy of the universe always increases in the course of every spontaneous process. So, second law related to entropy. Second law states that entropy of the universe always increases in the course of every spontaneous process. Now, let us combine the first law and second law. After combining the first law and second law, the statement is, in any natural or spontaneous process, the energy of the universe remains constant, but entropy of the universe always increases. See here, first law states that energy is neither created nor destroyed. So energy can be changed from one form to another form. That means energy of the universe is constant. So energy remains constant. According to second law, entropy of the universe always increases. So combining first and second law, we have the statement, energy of the universe always remains constant, but entropy of universe always increases in the course of a natural or spontaneous process. So in any natural or spontaneous process, the energy of the universe remains constant, but entropy of the universe always increases. This is obtained by combining the first and second law of thermodynamics. Please subscribe to my channel, like, share and comment on my videos. Thank you.